Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 66. I still can't believe we've done 60 of these things. This is stupid. Libretro Impl part 7. We're still working on serialization and deserialization. I believe I haven't streamed this in I think it's been like a month since I've actually worked on this on stream. So I'm a little bit behind, but yes, as I said, we're working on serialization and deserialization. The big problem we had last time is we have this basic setup where we're using Serde to actually serialize all of the state of the virtual emulator. So we copy out all the state into a serializable object, and then we have Serde actually serialize that object. A couple things wrong with this. Basically, it does totally work, but we end up with a file, I don't know if you guys can see this, that is 72 megs large and takes, if I recall correctly, a few seconds to serialize, which is really not gonna cut it. Okay, not that long actually in release, like half a second or something, so not too bad. By the way, hi to guys in the chat, Drew2, Zokwar, Love Like Semtex. A bit late on the announcement, so sorry about that. But I expect people to trickle in as normal as we continue. Anyway, the first things I want to do is I want to take a look at this. Oh, hey, Don170, and thanks for the bits. The first thing I want to do is take a look at this file that we generated and look at some things that we know we can do to make this better. In particular, I know for a fact that for example, the work RAM, the save RAM, all of that kind of stuff, I believe it's being serialized in a pretty dumb way. Just looking at this in a hexader, I wonder if I can zoom in here. Let's see. Well, it doesn't really matter, actually. But if you guys can see this, for example, this interconnect, we see the ROM here, and the ROM is written out as basically ASCII characters for every byte here. And that's pretty ridiculous. A couple things we might consider as quick wins is to do this as a binary format, but I would like to, if possible, keep this human readable. So I know, for example, BSON would be really nice for this instead of JSON, but we'll have to look at this. I believe, let me pull up the Serde stuff. And hey, Tom X, hey, Dark Second. Documentation here. Yeah, so we have different formats that this will use. I believe BSON actually is relatively human readable, if I remember correctly. So just as a quick test, I might actually output this as BSON just to see what we get. For this, need to look at this. Okay, we get state here. I believe, if I remember this correctly. Okay, where was this? Here we go. Serialize and deserialize up here. Are going to return a string. If we make this a vec of U8s, I think we'll be good enough for that. Okay, let's just try this. In fact, actually, we'll do. Look at this. The other thing I want to look at, I just want to do this as a quick test, but I suspect that what we'll end up actually doing is still using JSON, but if we can have some, adjust some serialization parameters so that we might be able to output this big binary blocks as like base64 or something, which should at least be a little smaller than the ASCII representation, although that still is going to be a bit overkill in terms of actual size. But 72 megs is ridiculous, so we really need to do something here. Wootness, thanks for the bits. Really appreciate that, you guys. So let's go ahead and just replace this with BSON. I think this is even saying BSON here, not Serde BSON. So that's a bit odd, I think, but let's just try it. And that was 0.11. I don't know how mature some of this stuff is, but it should be okay. Then that should take care of that. And then here we're going to use BSON and BSON to BSON, I think is what it's called. And this should, let's take a look at the proper documentation here. Search to BSON. Bloop. Actually, it's going to give us an encoder result of a BSON structure. That BSON structure is, yeah, I guess it's this top level structure, and then it just fans out, if I'm looking at this correctly. Actually, I'm hoping it's into a MongoDB collection, because we should get a document out of this, if I'm reading this correctly. And the document itself should, it's an ordered document. I actually want to look at the source for this. Yeah, string to other BSON objects. That makes sense. Yeah, I was hoping we'd be able to serialize this to basically binary. Maybe there's something on here that will allow us to do that. You can do like from JSON. That's kind of funny. Impulse, partial eq. Yeah, now I'm a bit lost. Yeah, I agree. Love like syntax. I think the biggest thing here is that we do want this to be relatively small, and I would give up human readability on this format if we can use something off the shelf that'll actually give this a lot more speed and make it a lot smaller. So I think we'll be okay with that. But yeah, I'm a little bit disappointed that this BSON thing isn't necessarily going to give us a string or like a vector of U8s. Like we would have to further deserialize the BSON after this. Maybe that's okay. There's also this bin code thing. Maybe that's easy to use. I mean, if we're going to use a binary format anyway. And it has the signatures that we want. So I'm actually going to try this instead of JSON or BSON, just to try and save some time here, because I don't want to write serializers for the individual BSON objects. And I didn't see them in the docs, but maybe I missed something obvious. So feel free to correct me if I did. In any case, let's see, this creates IOV1, so we'll do point here. That should have fixed that. And then here, evacuate, and then in this case, the S. We don't want S, we want the input to be a, whoops. Man, flying all over the keyboard today. Vector of U8s. Bin code serialize here. So we'll use code serialize here. This will be deserialize here on the input. Yeah, I actually kind of like that idea of like syntax is extracting blobs and storing them as binary alongside the JSON with refs. It's kind of annoying to have separate files that are referenced that way, but that might actually be a good middle ground here. We'll see how rough this is to get working. I expect this will not work because I think we'll have to change some of the top level code to actually dump this to the file, but we'll see. I believe this will give us some issues. Maybe not, though, because as bytes here might just work. No, it doesn't. But evacuate, I think we should be able to just deref this, and we should be okay. And that, I would imagine, works. Seemed to be quite fast. And now the output, first of all, it's .txt still, which is wrong. So this looks to be about 20 megs, still a lot larger than I expected. Make this a .bin just to make it non-ambiguous. And then I want to open that up. Let me pull this up here. There. So obviously it's not human readable anymore. But it's still a lot larger than I would have expected. Because what actually is in here right now? We also want to test round tripping this once it starts working better, but that's fine. This is bin code, by the way. Because we do, actually, this might make sense because we have the whole ROM as part of the save state, which we actually do want. Or at least a file path to the ROM. Maybe that's where we might fan that out. Because the ROM is read-only. And the only way you're, well, in order to make this general enough, I actually think I want the ROM as part of this. And in that case, actually, having this be around 18 megs makes a lot of sense. Did I close my Explorer window? I think I did. Pull that up again, or just ls here. And the reason is that this, I believe this particular ROM is actually 16 megs large. I'll actually pull this up in Explorer again. Okay, I don't know what is up with this. Yeah, bound high is the game we're testing. Okay, that's actually 2 megs. So that is a bit odd. You know, it might actually be save RAM as well, if this game actually has save RAM, and I believe it does. That would definitely explain the large chunks in the middle. Because when you consider that, when you consider it's a 2 meg ROM and then up to 16 megs of save state memory, then suddenly having a 19 meg dump actually makes a lot of sense already. And that actually sounds rather reasonable when it's binary encoded like this. And actually, I think that's okay if it ends up being this large, as long as it's a complete save state and the actual serialization is relatively quick. I'm actually going to do some timing tests on this just to see how long it actually takes. Just some simple profiling. But yeah, I switched this last minute. Sorry if you guys didn't notice that, but this is actually bin code, not VII. I'm sorry if I'm saying the wrong thing. But I think this should work. Yeah, that's also a good point, Daniel Collin. We could always like LZ4 compress this or something. Just as part of that chain, which would be quite fast. I might look into that actually, especially because we know most of the save RAM especially is going to be just default values that aren't actually touched by the ROM. So that's probably sensible. I imagine most of this would compress pretty well, especially like video RAM. I think we'll be okay. But at least this actually seems to be a sensible size when I start adding all that stuff up in my head. But first I want to see how fast this is to see if adding compression on the end of this is even feasible. I suspect it will be, though. I suspect that'll actually look pretty good. Okay. Also, Raises Gaming pointed out in VII you want to use encode document. I'm actually going to look that up really quick just so I can see where that is in the docs. And that signature is an asref str. Is that writing to that? Into a byte stream. Oh, key value in VII pairs. Yeah, that might be pretty interesting. But in any case, I think if I'm going to go binary, I might as well use... Like, it doesn't really matter which format we're using here, and bin code's probably okay. So we'll go with that for now, to see how fast this is. Now, I believe... we want these std time primitives we can use for this. Let's see. We need to get the current time. And if I remember that correctly, we should have system time here. Or no, we want to use an instance or an instant. And I believe we can do instant now. So we'll do that. So something like, we'll do this whole thing where we do the state and the serialization. For now, we can play with these a little bit more. So start instant is instant now. And then we'll serialize, and we'll also write out the file. I kind of want to do all of this. And then we'll do the end instant as the same thing. And let's duration is, I think we can do duration since. So we'll do end instant dot duration since start instant. Does that take a ref? No, that's just a whole instant. So we'll do that. And then the duration itself, we might be able to debug print this. I'll just try that. Whoa. There. Yeah, that's also a good point, Colin. If especially if disk speed is an issue, we could always dump this into an in-memory buffer and then have another thread actually write it to disk. Although I don't think we'll actually have any code to write to disk in our stuff. Okay, so this is what I kind of hate about this duration stuff is you get the seconds and then the nanoseconds, and you have to actually do the conversion yourself, which isn't terrible, but it's still pretty annoying. So we'll just do this many seconds. So I think for this we can do duration dot, let's see. Bunch of stuff here. Because we want like, we'll take the as seconds and we'll do the sub seconds. So I think this is subsec millis. Funny name. And that'll give us the U32 of the fractional part in milliseconds. And what we can do there, that'll be granular enough, I think. So we can do that as F64 over 1,000. That should be as many in a second. Or actually, since this is point, yeah, this is not the way we want to format this. We'll do this. That's seconds is duration as seconds as F64 plus the fractional part here. That should be okay. And we'll just do one hole here. Whoop, what did I mess up? Okay, apparently that's unstable, and I missed that here. But we can use subsec nanos, and then just convert up from there. So nanos, I believe, 1E9, I believe. I'll double check that. 1S in NS. Yeah, E9. And I think that might do it. And then it's about 1/4 of a second. I actually don't think that that is unreasonable. It's not as fast as I would like. Run it a few times to see how stable that is. Yeah, so it actually seems to be relatively unstable. I'm guessing that comes from disk, but it could be a lot of different things. In any case, it seems to be relatively fast. Don170, thanks for the bits. Really appreciate it, guys. I also, just to try this, I want to do a full serialize and deserialize. Because I bet if we do this, we can compare the two. Ruh-roh. VEC and then a result for the serialization. Right, so I think this. Unwrap that. Oh yeah, that gives us the state, not the vector of the U8 stuff, because we actually want if state is not different than deserialized. But I don't think we have partial EQ on those. I actually want to put those on there, just to be able to test this kind of stuff. I believe all we need is partial equality here and equality. And that almost works, except these all need this, actually. That's fine, I could just change all of them here. And yeah, there's another unwrap here with this VEC of U8s. This doesn't necessarily make sense anymore. Let's see what that does. By the way, I don't think my stream is going to be terribly long today. Probably about an hour, hour and a half. Right, so this is serialized state to unwrap. I'm actually going to... That actually takes this. Let's clone this here. Which I don't suspect is going to be much of an issue. And we don't have clone for state. So we want that as well. That's fine. That goes here. We definitely don't want copy on this. Clone should be fine. Change all these again. Rust compile times, man. It's still printing this, which is kind of funny. Don't think we need that. It's ridiculous. All right, let's get out of that and not print this. So this is full round trip encode and decode, and they match. And this is about 0.4 seconds, which is pretty good, I think. I actually wonder, because I believe there should just be a Rust package for LZ4. And I think there's going to be so much redundancy here that this is going to be worth looking into. Because the other thing is that we might... Yeah. Getting a little scatterbrained here. I don't want to use anything with LZ4 bindings. I want to use an LZ4 implementation if that's what we're going to use. Of course, we could use something else as well. Anyway, actually just on crates.io, there's I think a couple of these. No, hold up. LZ4 here. LZ4 compress is pure Rust. Seems to be fairly popular, so we can take a look at this. Check out the repo here. It's kind of cool to be able to just pull these packages so quickly. That's part of the RedoxOS file system even. It's kind of funny. Let's look at these signatures for compress and decompress here. And they're basically exactly what we want. So that is pretty rad, actually. Cool. Let's actually try this. Here. So we'll add... Oops. I'm using a Mac at work, so all my shortcuts are not in the hands. Okay, I'll do that, and then LZ4 compress here. Oh, wow, not big. Just going to read this comment out loud, you guys. Ferris, I'd just like to say that you are a personal hero and inspiration for me. Thank you so much. I started learning Rust and emulation through coding a Game Boy emulator, and I'm having lots of fun learning a lot. Or having lots of fun and learning a lot. I love to watch you code. You are a true inspiration. Would love to see Rustendo continue. Lots of love. Thank you so much. I really appreciate that. As I've said a few times before, I believe I will continue on the Rustendo project once I get Rustro Boy to 1.0. There's a tracking issue on the Rustro Boy repo if you'd like to see more about that progress. But I'll definitely go back to that at some point. Anyway, thanks again for the kind words. I really appreciate that. So the compress and decompress functions here, the nice thing is we can just serialize this straight out of here and then LZ4 compress exactly the output of that. And I think we deref here. Deserialization. Oh, yeah, this is compress. That should just work. Nope, it did not just work. Right, because I did map error here. We're going to do this. Map error dot map even. This is gonna get a little ugly. We'll do this. We'll do dot map here. This is. Expected result found reference. S and Dills, I feel you. Using Win 10, Linux, and OS X regularly comes with an hour of getting used to the OS of the moment. Absolutely, it does. Hey, Ashmadai. How's it going? So I would have thought... I don't think reordering these will actually help. I found reference. That's a bit odd here, because this compress should give us another VEC of U8. So if we have X here, this should be this VEC U8 already. Passing that to compress here should give us another U8 VEC. I believe this is correct. Considering bin code serialize. I'm a bit confused why this isn't working, actually. Yeah, sorry to throw you off, Osmodai, by shaving. That's funny. Yeah, that's a good call, Daniel Collin, to actually look at the repo and make sure the docs are up to date. That's a good point. Okay, at least the source link got us there, but that's still part of the docs, so I think we'll need to go ahead and check that. Now I think this gets us here, which should be okay. Look at LZ4 in here. This should be our LZ4 compress package. That looks correct. I need here. Let's look at tests. Okay, that just includes these. Coder. Yeah, so this does have the signature we expect for compress. I love like Semtex says, what was the graph drawing tool used in the hardware docs? Which hardware docs? I'm not sure what you're referring to. going to check this decompress thing here as well while I'm at it. And this also has the structure that we expect, or the signature that we expect. And the error type here, what kind of error is that? Oh, it's its own error type. We have debug here, though, so if nothing else, we can make good use of this. Anyway, from what I can tell, just realize here map should only affect the OK case. By applying a function to a contain OK value, leaving error value untouched. So the order here, this should be order independent, and then map error, which is right below here, applies a function to the error value, leaving OK value untouched. So I would expect this to be what we want here. Do I have a typo? Picture result found reference. Oh, it's here. Whoops. That makes sense the way I was piping this before. So it was taking a reference to this result value. Okay. Appreciate it, Raises Gaming. So that should be serialized, and then deserialized, of course, we need to match this as well. So what we actually will do here is first LZ4 compress, decompress the input. And I think, yeah, this will give us a result there. So we're going to map error here. Actually, instead of mapping, I think what I want to do here is map the error like we're doing here. This will be, let's see, 4. We can just use debug for this. And we'll do that. And then we can do map here, like we did before, and map the error out of that. I think this is what we want here. So here we have straight bounce here. Because decompress, what was this again? U8 into a vector, a result of vector U8 or error. So I think that part's what we want. And we're going to map this error into a string error. Oh yeah, because this will unwrap it here, so we actually don't need to map that. Let's actually do that though, just to make this easier, I think. This should unwrap this. Oh yeah, like some text. Yeah, that was Graphiz. I think I had some tweets about that. You might have to dig a bit to find those, but where I played around with that a little bit. I think I also do that on one of the Xenowing streams, but those are pretty long, so I understand if you don't want to dig through those either. Expect to type results. Box bin code error kind. That's not what we want. So I messed something up here. So this should give us a result of vector U8 or this error. So by mapping the error to a string, we'll have a vector result with vector U8 and the string. We can map that value Oh, this map error. It's a bit confusing the way I've written this. Yeah, I'm actually gonna do this in a couple different like steps to make this easier on myself, as my brain's not following this code as I'm writing it. So this will be the, we'll say let bin code is LZ4 compress decompress like this, and then we'll basically unwrap there. And then this here was wrong, I think. Whoops. And then we can do, we're not going to map here anymore, so we'll do that version state is this one. That'll be the bin code part here. Yeah, I think it's a bit more readable and it should actually work. It's gonna be cool if this just works. I actually would suspect that in serializing this stuff, we're gonna be disk-bound. But, you know, you never know. So it looks to be, run this a few times, just rather unscientifically. It's bumped up to about half a second from about 0.4 seconds. So 0.38 to 0.47 pretty stably. That's okay. And then the actual file size itself, if we just look at my Explorer window again, which I keep closing apparently. Yes, this is about 500K now, and that should actually be a lot more reasonable than 19 megs. So I'm actually pretty satisfied with that. I think that's what we'll do for serialization for this. And then I'm not too worried about the speed right now. Maybe we can look into that later, but I think this is basically as far as I wanted that to go. Just to make sure this is actually writing out this. Yeah, it is. I'm also going to not write out the file just to see roughly how fast this is without file IO. Okay, so not much faster at all. In fact, it's about the same speed. It's a bit interesting, but I guess when you're only writing 512K or so, this is not too bad. Anyway, I think I'm fairly happy with this chain here. I think I might also change the serialize function to be a little more symmetric. Yeah, so do the version state here, and then let bin code is this. Map error like that. And then we can do, okay, LZ4 compress this. I think that reads a little better, just comparing the two. Yeah, I was thinking the same thing, Daniel Collin. 512K is directly to Windows file cache, so yeah, I wouldn't actually touch disk. I think it's a bit larger than that, but still, it's going to be pretty good. Don170, thanks again for even more bits. Bit party today. Yeah, this was actually pretty rad. Okay, so I guess the next step with this is a couple things. First of all, we want to apply this to an actual Virtual Boy state. That would be the next step. I'm not sure if that's the part I want to implement, though. But we are going to need to do that relatively quickly here. I'm not really sure how I want to test that other than actually running it in RetroArch, which kind of sucks. I don't want to start adding like equality operators for the Virtual Boy structures because these are like live objects, if that's even a phrase that I can use, rather than plain old data objects, which is what the serializable stuff is. And I kind of want to keep that distinction. So, yeah. Yeah, Dan Colin, the thing that I'm serializing is the entire state of the emulator. We copy it out into its own serializable object. So we have, the ROM, work RAM, save RAM, video hardware state, audio hardware state, timer state, gamepad state, COM port state, CPU state, and yeah, so basically everything that we would actually need. Yeah, it's exactly it, Ashmedai. So it looks like we've got saving and also round tripping of those values basically done. It's really cool that this just worked by pulling in these other packages. So I'm pretty satisfied with that. And I'm also satisfied with the speed for now, I think. But yeah, the next thing we have to do is, just like we sat here and chugged, serializing into these, or copying the data into these serializable structs, we need to sit here and chug through applying the state stored in these serializable structs back to the actual live emulator objects. Tomic says, what can you do with the COM port? I thought there wasn't hardware release for it. There was not a link cable release for it, but other people have actually made those. And so the homebrew community uses it, and I actually use it for my testing framework. I modded one of my Virtual Boys recently to be able to send code over serial and be able to test, for example, CPU code running on the actual hardware versus the same CPU code running in the emulated hardware via the emulated COM port. So that's why we actually have emulation in there. It's a bit crude at the moment, but we have version save states, so I can fix that later. In any case, I'm feeling particularly lazy today, I'm not going to lie. In that I don't really want to do the code that applies the state back to the emulator yet. But maybe if I'm looking at this... Yeah, I think I'll just have to chug through it at some point. I should be able to test it outside of RetroArch, but I'm just thinking that it won't be much easier to do so. And I actually don't think the top level RetroArch parts for saving states is going to be that tough. I actually think what I'll do now, since I didn't plan on having that long of a stream anyway, why don't I start hooking up the serialization part to RetroArch, the RetroArch front, or the Libretro front end. And then we worry about deserialization after. Because we at least know the round trip encoded decode works. It's just applying it back to the emulator state. And actually saving out the save states in RetroArch is a good kind of milestone to stop this stuff at. Like if we can get that whole data pipe going, then that should be helpful. Yeah, I think I'll do that. So then we can go into this Libretro stuff. By the way, am I on a branch here? Libretro branch. Okay. I'm actually going to branch out again. Or I actually don't need to do that. I also have this thing here, which is just this test project. I'm actually not going to add that to the repo. So if you look at this, we have, yeah, all this stuff for this serialization structs and the lock files that have changed, and that's about it. So it's actually pretty good. Actually, I'll look at that one more time because I want to make sure that, yeah, here we go. Okay. Change serialized data format to LZ4 encoded bin code. Just push that. Now I think, let's see, I should have the Libretro API up here in these tabs that I've kept open for months now. Let's see. Change my music here. Okay, let's see. I don't remember exactly what this looked like. Let's just pull this up here. So Yeah, so we have retro serialized size and retro serialized and unserialized. I think this is the API that we need to implement here. I think between calls to retro load game, retro unload game, the return size is never allowed to be larger than a previous returned value to ensure that a front end can allocate a save state buffer once. That actually kind of sucks with the fact that we're using compression, because like we might have to make this really conservative. I'm actually really unhappy with that. Probably should have looked at this before actually working on the format that we were going to save this in. But I would have assumed that we could have given like an arbitrary size and it would just save that out. Not thrilled about that. That's really a bummer. This basically means that all save states are going to be like 20 megs. The nice thing is, though, is that if we could remove the LZ4 layer and then just use bin code, and then I think that will still give us something of a consistent size, except it won't because the SRAM size is dynamic as well. So we would have to just always serialize the maximum available SRAM. I'm so not happy with this. But I believe I'm interpreting this correctly. I'm going to take a 5-minute break and have a think about this. I'll be right back. All right, so Daniel Collins said it might be that the size you return here is like a maximum size, so it would just do a save state buffer, like allocate that once, and then serialize and unserialize here would actually write out the data. What I don't like about what's going on here is it looks like these give you a size, probably the size of the save buffer, and you write out the data to this pointer. Or in this case, read the data from this pointer, which are presumably the same, but they don't have to be. The problem here is the serialize function has no way to write out the amount of bytes you actually wrote. So it looks like we would have to do a maximum size here, and then it probably uses all of that space for its saving anyway, even if we use a compressed thing to make that smaller. And that sucks. I mean, at least we can, like the maximum size is bounded, so we should be able to do that. But yeah, I'm not very pleased with this. Exactly. Those emojis are exactly what I'm feeling. Basically dread. Now I wonder though, so here's actually something kind of interesting. Just searching serialization or serializing this API, we see these serialization quirks. It's kind of interesting. So it might be incomplete save state, which is not going to be the case here. Must initialize means that this will initially fail, but we don't need that either. Here's something that's kind of cool. Serialization size may change within a session. Maybe that allows us to bypass the limitation on the other part of the API. Yeah, this core variable size thing, that might get us around this. I'm not actually sure. Serialization size may change. Set by the front to acknowledge that it supports variable size states, which is also the case. Serialization can only be loaded during game session. That's not the case. Serialized state cannot be loaded on an architecture with a different endianness from the one it was saved on. That's a funny but very necessary quirk to have support for. Ugh. Your serialized state cannot be loaded on a different platform from the one it was saved on for reasons other than endianness, such as word size dependence. That's kind of funny. Anyway, it looks like we can do a callback to the environment to set these quirks. That might get us around this. I just want to search for more serialization stuff in this API in case we missed anything. But I can imagine that if core variable size, serialization size may change within a session, I would assume that other invariant that was mentioned on the serialize function where we can never return a value from this that's smaller than a previous value, or sorry, larger than a previous value, I assume that we can break that invariant if we have this quirk set. I can't imagine why else one might use this. But that would be really nice if that gets us around this. So yeah, we can look into that. Yeah, quirk is a weird name indeed. But at least it's readable enough. Environment. So where did I end up with these environment callbacks? Probably in here. Yeah. That's brutal, Dana Cullen. Yeah, capability would have been a better name for that, for sure. The front variable size is something that we specify. So it's not that we read it from the environment. We tell the environment this is going to be the case. So I think we'll try setting this and then always use compression and see what happens. That seems sensible to me, at least. So what I'm going to do is I'm just going to start adding some of these things here. I hate that that's actually real, Dana Cullen. Quirk. Or was it core variable size? Hey, Michael McMillan. And we'll use front variable size as well. Oh, wait a minute. Oh, now I see. This is actually set by the front end to acknowledge that it supports variable size states. So I guess we would have to check that. The front end will zero any flags it doesn't recognize or support. It should be set in either retro init or retro load game, but not both. Ugh. That's really annoying. Because you basically want to set core variable size and check that front variable size actually works. I might even disable serialization if this is not the case. We'll have to see. But we're actually passing the hour mark, which is as long as I wanted to stream today. So I actually think I'm going to go for now. I know it's kind of a weird point to cut off the stream, but I think that's what I'm going to do. Maybe I'll think a bit more about this over the next week, but we should be back on schedule to stream again this Sunday and next Thursday. Actually, wait a minute. No, next Thursday I will not be streaming because it's a Norwegian holiday. So I guess we'll be back at this in 2 weeks. But anyway, thanks guys for hanging out, and I'll see you next time.